Welcome back to the Building Code Pros podcast, your expert resource for navigating the world of building codes. In today's episode, we're taking a closer look at a crucial topic. Let's get started. So, that crucial topic for us today. It's basically the ultimate planning checklist. We're doing a deep dive into the 2024 International Residential Code, Chapter 3. This chapter, it really is the absolute foundation for any sound residential structure, isn't it?
It really is. Think of it as where risk management really meets the architecture.
Yeah.
It's your mandatory pre-construction checklist. It defines how the building envelope is going to resist, well, everything the environment throws at it. Wind, snow, even seismic forces.
Yeah.
And also how the building contains internal hazards, like fire.
Right. So our mission today is let's cut through the jargon, find those practical requirements for resilience, fire safety, everything from handling snow loads to making sure that garage door closes properly.
Absolutely. For any building pro listening, or even a serious DIYer, getting these concepts down, structural integrity and fire barriers, it's the non-negotiable first step. Compliance starts right here with R301.
Okay, so let's start where, every engineer probably starts. Structural integrity. R301.1, load management. It basically says the building has to support all the loads safely. Dead loads, live loads.
Everything. Roof loads, flood, snow, wind, seismic, all of it.
But the part that seems to trip people up, or at least where I see questions, is this requirement for a complete load path. What exactly are we talking about there?
Yeah, that phrase, complete load path, it's really the key to code compliance here. It means every single load, whether it's the weight of the drywall or people walking around or, a heavy wind gust, that force has to be continuously and safely transferred from where it starts, say, a roof rafter, through every single connected element, all the way down, uninterrupted, to the foundation.
So it's less about the sheer size of the stud or the beam itself and more about the connections. Is that fair?
Precisely. That's exactly right. Load path failure, it almost never happens in the middle of a perfectly good piece of lumber. It happens at the weakest link. That's usually the hardware, the fastening schedule, or maybe those critical connections like shear walls to the foundation or between floors. If you miss a crucial hold down, maybe you use the wrong nail pattern on a strap tie. Poof, that load path is broken. And the building's technically non-compliant. Doesn't matter how strong the individual walls might seem.
Okay, that makes sense. Now, the IRC gives us this prescriptive design path, kind of the standard recipe book. But the code, it does allow for alternatives under R301.1.1. If you step outside that default IRC path, what are the main standards people reference?
Well, for wood construction, you're almost immediately looking at the AWC Wood Frame Construction Manual, the WFCM. Or if you're doing a cold-formed steel project, it's the AISI standard, S230 usually. These are really comprehensive design guides that the IRC specifically calls out as, acceptable alternatives. They do the nitty-gritty calculations.
Which kind of leads us straight to the engineered design threshold in R301.1.3. When does a project stop being a standard prescriptive build and suddenly need like a PE stamp?
Right. So if any structural part of your design goes beyond the limits set in R301 itself,
right,
or maybe you just choose not to follow the conventional framing methods described in the code, that's when you cross the line. That specific element, or maybe the whole system, has to be designed and stamped by a licensed engineer using accepted engineering practice.
And critically, I imagine that engineered part has to play nice with the rest of the structure.
Oh, absolutely crucial. The engineered design has to be fully compatible with the conventional system you're using elsewhere. You can't, for instance, have some super rigid engineered element dumping forces into a conventional wall that just wasn't designed to take it. It all has to work together.
Okay, so we've got the basic structural rules down, but then the building has to actually exist somewhere, right? Location, location, location. R301.2 forces local jurisdictions to set critical design criteria based on their specific geography. So a house plan for Miami is going to look totally different from one for, say, Denver.
Totally different. Yeah, we really rely on the local building department to adopt and fill out table R301.2. That's where they'll specify things like the ground snow load for their area, the required frost line depth, termite infestation probability, and really importantly, the ultimate design wind speed, what we call yield, and the seismic design category, or SDC. For you, the builder or designer, those numbers in that table, that's your specific design brief for that location.
Let's zoom in on wind for a second. It gets complicated fast. Where does the IRC's sort of simpler approach tap out and you have to get into more advanced engineering?
That line in the sand is pretty clear. It's drawn at 140 miles per hour, specifically if you're in what's designated as a special wind region. R31.2 1.1 basically says if your yield hits or goes over 140 miles, you have to stop using the basic IRC prescriptive tables for wind design, full stop. You then have to switch over to using one of the more advanced standards like the WFCM we mentioned, or maybe ASC 7. That 140 number is the trigger.
Okay, 140. Got it. And wind forces aren't just about speed, they're also heavily affected by the surrounding terrain, right? These exposure categories.
Exactly. The landscape dramatically changes the stress on the building. So exposure B is kind of the default assumption. Think urban or suburban areas, lots of houses, trees, things breaking up the wind flow. Then you have exposure C. That's more like open terrain, flat prairie, maybe scattered farms, where wind can travel a long way without hitting much. And the most severe is exposure D. That's reserved for sites right on flat, unobstructed areas facing open water. Think coastlines. If you're building near the coast, you're likely dealing with the highest wind forces the code plans for.
Okay. And practically speaking, for builders or even homeowners in those windborne debris regions, hurricane zones, basically how do we protect windows and doors? This seems like a detail everyone needs to nail.
Yeah, protection of openings, glazing specifically, it's critical. It generally needs to meet specific impact standards like ASTM E1886 and E1996. But there's a practical alternative, the one a lot of contractors use, especially for temporary protection during construction or a storm threat. That's using wood structural panels, plywood or OSB, not less than 7/16 thick.
Okay, 7/16.
But just having the panel isn't enough. The insulation is absolutely key. For instance, if that panel spans, say, 4 feet or less,
Yeah.
you've got to secure it with corrosion-resistant fasteners like number 8 wood screws, spaced no more than 16 inches apart around the entire edge.
16 inches. That's specific.
That's specific. If you use the wrong spacing or the wrong screws, that protection is considered non-compliant, even if the panel itself is thick enough. The fastening schedule matters.
Good to know. Okay, let's shift gears from wind to the ground shaking. Seismic design. This relies on seismic design categories, SDCA through E. In simple terms, what does getting a higher letter, like D or E, mean for the actual structure?
Well, the SDC rating, it's basically a measure of how hard and fast the ground is expected to shake in a major earthquake. It's based on something called the short period spectral response acceleration. A higher letter, like D or especially E, means you can expect faster, more aggressive shaking. And that requires much tougher structural reinforcement, more bracing, stronger connections, that kind of thing. SDCE is usually the point where the basic IRC provisions aren't considered sufficient anymore. You typically have to default up to the International Building Code, the IBC, for design standards.
Is there any escape hatch from having to use the full IBC if you find yourself in an SDCE location?
Yes, there is a potentially very important reclassification allowed under R301.2.2.1.2. If you're building an SDCE, you might be able to reclassify the design down to SDCD2, and that lets you stay within the IRC framework if your structure meets the definition of rating.
Regular. What does that mean?
It means it has to meet some pretty strict geometric criteria. Things like having all your exterior shear wall lines stacked neatly in one vertical plane, no major offsets or cantilevers. Basically, it rewards simple, symmetrical building shapes.
Okay, so R301 keeps the house standing. R302 is about keeping the people inside safe, right? Managing internal risks, primarily fire. This seems especially critical when you've got shared housing. Let's start with townhouse separation. That seems like a high-stakes area.
Oh, absolutely high stakes. You're dealing with dividing ownership, but more importantly, life safety between families. The code gives you two main ways to do it. You can use the double wall system that's basically two separate 1-hour fire resistance rated walls built side by side, or you can use the common wall system.
Okay, that common wall option, R302.2.2, it says it has to be continuous foundation to roof sheathing. And crucially, the cavity inside that wall can't have openings, plumbing, or ducts. That sounds incredibly restrictive.
It is restrictive, and for good reason. That common wall is the primary barrier against fire spreading from one unit to the next. Its required fire resistance rating is actually 2 hours if the building doesn't have sprinklers. If it does have an NFPA 13D sprinkler system, then it only needs to be 1 hour rated.
2 hours unsprinkled, 1 hour sprinkled.
Got it. And that no penetration rule. It's because any hole, any pipe, any duct running through that cavity compromises the integrity. It creates a path for fire, smoke, hot gases to just shoot right through, unseen. The only penetration explicitly allowed is for water-filled fire sprinkler piping itself. If you need to run other utilities like plumbing or HVAC, you pretty much have to build separate chases or framing next to the common wall, not inside its rated cavity.
Makes sense. What about where townhouses meet at the roof? The parapet requirement in R302.2.4, do you always need that wall sticking up?
You need that parapet typically extending 30 inches above the roof deck whenever the adjacent roof surfaces are at the same level or very close in elevation. The idea is to stop fire from easily hopping over the wall from one roof to the other. However, there's a really common and practical exception. If you use at least a Class C rated roof covering and you install a layer of 5/8" Type-X gypsum board directly under the roof sheathing, extending 4 feet out on each side of that common wall line, you can usually skip the parapet.
Ah, so that layer of Type-X under the sheathing basically buys you out of building the parapet.
Exactly. It's often a much cheaper and cleaner looking solution than building a masonry parapet up there.
Okay, let's shift to maybe the most common fire separation issue I see questions about, the
Yeah.
garage. R302.6 and R302.5. What's the basic separation needed between the garage and the house?
The minimum is 1/2" gypsum board, regular drywall, applied on the garage side of any walls or ceilings separating it from the dwelling unit. However, if you have actual habitable space, like a bedroom or living room directly above the garage, then the requirement for the garage ceiling bumps up. It has to be minimum 5/8" Type-X gypsum board. Garages are inherently hazardous spaces, so that ceiling needs extra protection.
Right. And the door between the garage and the house. I swear I've seen beautifully built homes almost fail inspection just on this one detail.
Oh yeah. R302.5.1 doesn't mess around. The door itself needs a certain level of fire resistance. It has to be either solid wood, at least 1 3/8 inches thick, or solid or honeycomb core steel, same thickness, or an actual tested 20-minute fire-rated door assembly.
Okay, so the door material matters.
It does. But here's the part everyone seems to miss, or maybe hopes the inspector won't notice. It must be self-latching, and it must be equipped with a self-closing or automatic closing device.
Both. Self-latching and self-closing.
Both. Mandatory. I remember seeing a project where the contractor installed a gorgeous, properly rated fire door. Looked great, but they just used standard hinges. The inspector opened it. Let go. And the door just stayed open, instant fail. That door has to swing shut and latch securely behind you every single time automatically.
Wow. Okay, good reminder. Finally, under fire resistance, let's talk about something you don't see once the walls are closed up. Fire blocking in R302.11. Why is this so important and maybe easily overlooked?
Fire blocking is like the internal hidden defense system. Its whole job is to cut off those concealed draft openings inside wall cavities, between studs, under stairs, things like that. It prevents fire and superheated gases from having an easy hidden pathway to race vertically up to the next floor or horizontally across ceilings into the attic. It buys crucial minutes in a fire. And yeah, it's easily overlooked because, well, you cover it up immediately with insulation and drywall. Out of sight, out of mind.
So where exactly do we need to install it in, say, standard wood-framed construction?
Okay, key locations. You need fire blocking vertically at every floor level and ceiling level, essentially sealing off the connection between stories within the wall cavity. And then horizontally, inside concealed stud walls, you need it at intervals not exceeding 10 feet.
10 feet horizontally. So if I have a tall, say, 16-foot wall in a two-story space.
Yep, you'd need to put a horizontal fire block in there somewhere around the midpoint, breaking up that vertical chase. It's also required at other interconnections, like where walls meet soffits or cove ceilings. And critically, around any penetrations, think pipes, ducts, chimney flues, wiring passing through floors or ceilings. Use approved materials like nominal 2-inch thick lumber, 1/2-inch gypsum board, or even bats or blankets of mineral wool or glass fiber, as long as they're installed securely to fill the space.
Okay, that's a lot of detail. To try and pull this all together, let's run a quick practical scenario for our listeners. Imagine you're planning a new 2-family dwelling, a duplex, maybe side by side with an attached garage. And let's say the local jurisdiction has told you, okay, you're in a moderate to heavy termite infestation risk zone, according to their maps. And it's a fairly high wind zone with an ultimate design wind speed VOLT of 120 miles per hour. What checks from Chapter 3 immediately jump out?
Right, good scenario. Based on what we've discussed, at least 4 immediate compliance checks rooted in Chapter 3 spring to mind. First, termite protection. That's R305.1. Given that moderate to heavy risk designation, you must implement protection. That could mean chemical soil treatment before pouring the slab, using preservative-treated wood for all your sill plates and any wood touching the foundation, as per R304.1. Or maybe even choosing to frame the whole thing with cold-formed steel. If the risk was bumped up to very heavy, you'd also have severe restrictions on using foam plastic insulation below grade unless it was specifically protected.
Okay, termite treatment is step 1. What's next?
Second, wind design, R301.2.1. That 120 mile per hour EV is below the 140 mile per hour trigger, so that's good news. We can likely still use the prescriptive tables in the IRC. However, we still absolutely have to determine our exposure category, B, C, or D, based on the actual site conditions. Is it open terrain, suburban, near water? Once we know the exposure category, we use the tables in R301.2 to find the required design pressures for components and cladding. That means walls, roof, windows, doors. Every exterior element has to meet those calculated pressures.
Got it. Check the exposure, find the pressures. What's third?
Third is unit separation, R302.3, because it's a two-family dwelling. Those two units have to be separated by a fire resistance rated assembly. Minimum 1 hour rated, whether it's a vertical wall between them or a horizontal floor ceiling assembly if they're stacked. Now that rating could potentially drop to just a half hour if the entire building is protected by an automatic sprinkler system meeting P2904. And you also need to pay attention to rules about smoke transfer and maybe extra alarms if the units are stacked vertically and you don't have sprinklers.
Okay, unit separation is critical. And the fourth check. I bet I know this one.
You probably do. It's the garage interface, R302.5 and R302.6. This is almost always a guarantees inspection focus point. You need that minimum half-inch gypsum separation on the garage side. If there's living space above, it's 5/8 type X on the ceiling. But the absolute must-get-right detail is that door connecting the garage to the house. It needs the proper fire rating, like 20 minute. And it must have both the self-latching hardware and that self-closing device installed and working properly. No excuses, no exceptions on that one.
Okay, fantastic walkthrough. So let's try to boil this down. What are the absolute key takeaways from this Chapter 3 deep dive?
All right, takeaway number one for me. The concept of a complete load path is absolutely fundamental to structural integrity under R301.1. It's not just about big beams. It's about ensuring every force gets transferred continuously down to the foundation. Your connections, your hardware, they're just as critical, maybe even more so.
Okay, my main takeaway. Your site location is your design specification. You absolutely have to get those local parameters from your jurisdiction's adopted Table R301.2 wind speed, seismic category, snow load, termite risk. Ignoring that table or guessing, you're basically planning to fail the design review or inspection. It dictates so many downstream requirements.
Good one. Third, I'd say when you're dealing with shared walls, like in townhouses, or the connection between a garage and the house, pay extreme attention to those vertical fire separations. That means verifying the correct fire resistance rating, usually 1 hour or maybe 2 hours if unsprinkled, and hammering home the absolute necessity of that self-closing and self-latching door for the garage. It's a life safety linchpin.
Absolutely. And my final one, maybe the unsung hero. Don't forget about fire blocking under R302.01. Pay attention to the parts of the house you won't see once the drywall goes up. Just remember the basic rule. Fire blocking needed vertically at floor and ceiling lines and horizontally every 10 feet inside those hidden wall cavities. That's your primary internal defense against rapid fire spread.
Well said. And maybe let's leave everyone with one final kind of provocative thought that ties R301's structure and R302's safety together. It's the subtle but potentially devastating issue of material compatibility, specifically with fasteners. We touched on corrosion resistance earlier. If you use the wrong type of metal hardware, say, just a standard electrogalvanized nail or screw, instead of the required hot-dipped galvanized or stainless steel fastener. When you're connecting framing members to preservative-treated wood, or maybe fire-retardant treated wood, you are setting yourself up for rapid corrosion. That seemingly small mistake can completely undermine the load path you so carefully designed. It compromises the structure way before its time. So always, always check your fastener coatings against the material you're attaching to.
Great point. Check those coatings. And that's our breakdown for today. We hope this gives you a clearer understanding of the topic. For more articles and resources, be sure to visit buildinghodepros.com. Join us next time for another episode. Thanks for listening.